Hey, what's going on, guys? In this video we are going to see how to solve a homogeneous differential equation. Now in order to do that, we have to look at the degrees and see whether we have the same degree in each term. Then only it's going to be a homogeneous differential equation. And here we can see that degree is 3 right here, so everything should be 3. Now this is 3 and this is 2 and x is 1, right? So 2 plus 1, that's 3, y is 1, x is 2, 1 plus 2, 3, 1 plus 2, 3 and 3. So this is a homogeneous differential equation. Now after we find this one out, what we do is we try to convert everything in terms of y over x. Now to do that, what we do is we take the degree. Here the degree is 3, right? 3 in everything. So what we do is we multiply this one by 1 over x cube. So this is the degree. If it's 4 degree, we multiply by 1 over x power 4. Since we have 3 degree, we multiply this one by 1 over x cube. If we multiply top, we have to do the same thing in the bottom. So we have to multiply the bottom also by 1 over x cube, right? After we multiply, we had to write everything in terms of y over x pattern, and if you notice, the first one is y cube, and if you divide by this one, that's going to be y cube over x cube. We can write this one as y over x whole cube, right? And the second term is going to be 2y square divided by 2y square x divided by x cube. That's going to give us 2y, actually 2 times y square over x square. We can write this one as 2y over x whole square. And then the third term is going to be y over x, and the fourth term, the bottom part is going to be y over x plus x cube over x cube. That's going to be 1. Now we have written everything in terms of y over x. Then what we do is we take v is equal to y over x. Then we substitute v instead of y over x. Now let's go ahead and do the substitution. Here we are going to have v cube plus 2v square minus v over v plus 1, right? So this is what we are having. Now if we convert this one into v, we have to do the same thing to the other side. Other side we have dy over dx. Now we should try to write this one in terms of v. And here what we do is, if v is equal to y over x, y is going to be equal to v times x. Therefore dy over dx is going to be d times vx, because we know that y is equal to vx, so we substitute that one right here, d times vx over dx. And if you differentiate this one, that's going to give you 1v plus x dv by dx. So now instead of dy over dx, we substitute this one in this equation, and we can write this one as this is equal to v plus x dv over dx. Now let's bring this v to this side. So we are going to have x dv over dx, and if I bring this v to this side, that's going to be minus v. So this is going to be v cube plus 2v square minus v over v plus 1, and I'm bringing this v to this side, that's going to be minus v. And if I want to combine this one with this one, I can take v plus 1 as common denominator. In that way, this will become v cube plus 2v square minus v, and this is going to be minus v times v plus 1, right? And if you simplify this one, that's going to be v cube plus 2v square minus v square plus, actually minus v again, minus v square minus v, and in the bottom we are going to have v plus 1. And also we can simplify this one furthermore, like we have 2v square minus v square, that's going to be v square right here. This is going to be v cube plus v square minus 2v divided by v plus 1, and this is the simplified form. And after that, what we do is we separate. If you notice, this is separable right now. Now we have to separate and integrate. After we find out separable pattern, we separate and integrate. Now let's continue this part on top, right? And this part, let's get rid of this part for now. We just need to know v is equal to y over x, because at the end we had to write everything in terms of y over x. So we had to write this one back like v is equal to y over x. That's what we previously took. So let's note this one for now right here, and I'm going to continue this one right here. And x dv over dx is equal to this one, v cube plus v square minus 2v v plus 1. Now this is separable, so we can bring all the v values to one side, all the x values to the other side. Since we have dv on the numerator in the left side, we can bring all the v's to the left side. So this is going to be v plus 1 dv over v cube plus v square minus 2v, and in the other side we are going to have 1 over x dx. Now we have to integrate both sides. Integration, right side is easy, but left side we have a problem because this is not an easy integration, right? So what we can do is, let's try to simplify this one. Like, first what we can do is, in the denominator it's factorable, like, because we can take v common. So let's go ahead and do that. V plus 1 integration v plus 1. Now let's leave this right side alone for now, and let's try to integrate this one, v plus 1 dv, and if I take v common, this is going to be v square plus v minus 2v, actually 2. Now here we can, it's look like we can factor this one furthermore. Like, when we multiply we have to get -2, when we add we have to get +1. So this one will work with the 2 and -1, right? Because 2 and -1, if you multiply you will get -2, and if you add you will get +1. So we can factor this one as v plus 1 dv over v, and v plus 2 v minus 1, right? And after we factor like this, and if we can get a factor like this, it means we can use the partial fraction decomposition. So let's go ahead and do that. And if you remember, partial fraction decomposition is when we have this value, we take this part alone, like v plus 1 over v plus 2 v minus 1, and in the other side we write each bottom parts, we separate them into 3 parts, right? Because we have 3 different functions. So v, and we put a, b, c, like a over v plus b over v plus 2, and then plus c over v minus 1. And after we write like this, we multiply this both side by the denominator. So we can cancel this denominator and equate this one. So this is going to be, we multiply this one by v times v plus 2 v minus 1. Other side also we do the same thing. We multiply this one by v times v plus 2 v minus 1. In that way we are going to have, so let's continue this part after this, right? Now we are going to have maybe we should write this one right here because we have a lot of space here. So let's get rid of this. Okay, so now we have this one. So I continue this from here, and v times v plus 2 v minus 1. If you notice, the denominator is same, so these two cancels each other, right? So we are going to have v plus 1 is equal to, here if you multiply this one with this one, v cancels but others remains. So we are going to have a times v plus 2 times v minus 1, and plus b times v plus 2 cancels, other 2's will remain. So this is going to be v times v minus 1, and then the third one is going to be c, and here v minus 1 will cancel, so v times v plus 2 remains. Right, now what we have to do is, we have to pick up some value such the value should cancel, like for example we have to get 2 zeros In such way 1 will remain and we can find that value. Now let's see what is the v value we can pick. First of all, let's take a look. If I pick 1 right here, this one becomes 0, this one becomes 0, so I can calculate c. So if I take v is equal to 1, this side is going to be 2, right? If v is equal to 1, this side is going to be 1 plus 1, 2, and this will become 0 because 1 minus 1, this whole thing will become 0, this whole thing will become 0, this will remain. So this is going to be c times 1 times 3. So that's going to be 3c is equal to 2. Therefore c is going to be equal to 2 by 3, right? So we found out c. Now we have to find a and b. Now we have to look at a value in such way that value make other two 0, and also negative 2 will make this 2 0, a and c, because we have v plus 2, v plus 2. So let's pick if v is equal to negative 2, these two are going to be 0, right? A and c. Now if I put negative 2 for this one, this is going to be negative 1 is equal to, we are going to have this b alone. So b times negative 2, negative 2 minus 1, that's going to be negative 3. So this is going to be positive 6 b. Therefore b is going to be negative 1 over 6. Now we found out b value. Now a is the only thing that is left, and we can substitute in one of the equations. Let's see. If this is this is this, a is going to be what? Okay, let's see. Okay, so 1 is equal to v plus 1, this one. Okay, so v is equal to 0. If v is equal to 0, oh yeah, if v is equal to 0, these two will cancel, b and c will cancel. So in that way we can find a. V is equal to 0, these two are going to be 0, this is going to be 1. 1 is equal to 2, and this is going to be negative 1, right? So a times 2 times negative 1. Therefore a is negative 2, a is going to be 1. Therefore a is going to be minus 1 over 2. Now we have a, b, c value. Now we found out because we are trying to integrate this part. That was the hardest part, right? Now let's go ahead and now we can do the integration. Now what we can do is we can write this one like a over v, b over v plus 2, c over this one, and do the integration. Now let's do the integration, and a is negative half, so this is going to be negative 1 over 2 v, and plus b is negative 1 over 6, so this is going to be minus right here, minus 1 over 6 v plus 2, and then we are going to have c, that is 2 over 3 v minus 1, and we are going to integrate in terms of dv. And if you, now it's easy, if you do the integration, this is going to be just half ln of v, and this one is going to be minus 1 over 6 ln of v plus 2, and this is going to be plus 2 over 3 ln of v minus 1 plus constant. Okay, now we have integrated this one, and this integration was equal to this one. So now we have done with this part. Now this other side of the equation, we had 1 over x dx, that is ln absolute value of x let's write this one with different color. I have to separate this one. Okay, so this is equal to ln of x plus constant. Now let's get rid of this constant and put it as together. So this is equal to ln x plus that is equal to ln x plus constant, and that's going to be the final answer if we have situation like this, and this is going to be final answer. But before I write the final answer, I had to substitute this y over x, because initially we had y over x, so we had to do the back substitution to write everything in terms of y and x. Now let's get rid of these parts right here and write our final answer, right? Okay, so the final solution, the general solution for this differential equation is going to be minus half. Okay, I am just copying this one. Minus half ln, instead of we plug y over x, and minus ln minus 1 over 6 ln 1 over 6 ln y over x plus 2 plus, okay, yeah, plus 3 by 2 ln y over x minus 1 is equal to ln of absolute value x plus constant, and this is going to be the general solution for this differential equation. I hope you guys find this video helpful. See you next time.